Welcome to our first practical lesson in this chapter. It's going to be a quick one. I want to refactor the code that we have inside of the DevHabit application to make it more organized and easier to work with in the upcoming lessons. We will be introducing a lot of additional abstractions in the lessons to come, and I want to have a good foundation for that won't introduce a lot of confusion for you. Let's jump into the code and I'll show you what I mean. If we take a look at our program file where we are configuring our services with dependency injection and a couple of other things, you can see that it's grown to almost 100 lines of code. Now, a large part of this is the namespaces that we need for all of the services that we are registering, but also our services are becoming a bit cumbersome to find our way around. For example, we are registering the controller services, validation, problem details, exception handlers, open APIs, our database context, open telemetry, and then we have a couple of application services, and we are just getting started with these, and we'll have a lot more in the upcoming lessons. So I want to restructure this to make it more organized and make it easier for us to evolve this in our upcoming lessons. So that's one thing I want to do. The second thing is I want to get rid of some remnants from our initial scaffold with the weather forecast controller and the record. So let's begin with that. I'll delete the weather forecast DTO that is used in the weather forecast controller. Let me also open up the controllers folder, and here I want to remove the weather forecast controller. One more remnant of this is inside of our HTTP file, where I had a base endpoint that was sending a GET request to the weather forecast endpoint. So I will remove this and I'm done with my first step. The second step is restructuring my service registrations. So for this, I will use this approach with a single class that I'm going to call dependency injection. And what I want to do is to move one piece of code after another into that class, but inside of nicely scoped methods. So let's start from the top. What do we need to do to move these few lines of code into our dependency injection class? First, I need to make it static so that I can define some extension methods inside. And then the extension methods should be defined on some type. And for example, this could be the web application builder. And let's say I define a method called addControllers. Let me make it an extension method on the web application builder type. And then what I can do is just paste the code that I already had inside of my program file. Then I'll return the builder, and now I can remove this code from the program file and simply call my new extension method. So let's call addControllers and let's get rid of the using statements. What else could I fit into this method? For example, let's move the open API services there. Let me paste down this line of code, and then let's see what is the next thing that I can update inside of the program file. Let's say the next thing I want to move is the problem detail services and my two exception handlers. So I will take them out and I'll define another extension method here. So let's say public static web application builder, and let's call this add error handling. I'll define the web application builder to make this an extension method, and then let me paste in the services that were previously in my program file. So let me complete my extension method, and then I just need to call this from the program file. So I'll begin chaining these calls. Right after introducing controllers, I will say add error handling. I can also get rid of the using statement, and I'll continue in this fashion. So the next thing I want to move is the database context. Let me move that, and let me define an extension method to hold this code. I'll call it add database, and I can move my code for registering my database context into this new extension method. Let's call it from our program file. I need to say add database, and we're one step closer to achieving our goal. Then let's move the observability services into their own method. So let me define this extension method in the dependency injection class. I will call it add observability, and inside of this method I will just paste the code that I took out from the program file. So defining these extension methods on the web application builder gives me access to the service collection so that I can register my services, but it also makes it easier because I also have access to the logging builder as well as the iConfiguration to be able to retrieve configuration values. It might not be the most standard way to achieve this, but it's a good means to an end. So let me add the observability services, and the only thing that's left here are some services that are application specific, like the Fluent validators, our sort mapping provider, our data shaping service. So all of these can go inside of one new method that I'll create. So let me add this method at the end, and I'm going to call this method add application services. Inside of it, I'll just drop the piece of code that was in my program file, and now I need to call this method to register my application services. And this is what we are left with in the program file, from 90 lines of code down to under 30. Also, in the dependency injection static class, I now have methods where I can easily group similar services together inside of these helper methods. If these helper methods also grow out of control and become too long, I can move them into their own files to further simplify my organization. So I'm pretty happy with this, and I think we can wrap up this quick refactoring lesson. And we can move into our next lesson, where I will show you how we are going to implement support for HateOS inside of the DevHabit RESTful API. We have been talking about hypermedia in the past couple of lessons in this chapter, and it's finally time that I show you how to implement hypermedia inside of an ASP.NET Core RESTful API. So let's jump into the code and let's see what we're going to build. Let's start from the habits resource and the respective habits controller. This is where we have spent most of our time in the previous lessons, and I assume you are the most familiar with the inner workings of this controller. We'll be implementing support for HateOS when returning a collection of resources. This is our getHabits endpoint, but let's begin by introducing support for HateOS when fetching a single resource. This will make it easier to explain the concept while demonstrating the value of HateOS. So the first thing we need is a way to represent a single link. I'll introduce a new DTO in the DTOs folder, and I think an appropriate place for this is the common folder. So let's go ahead and add a new type inside, which I will call a link DTO. So what do we need on this type? We need a couple of string properties, and I want to make them required values. The first one is going to be my href value, which is a fully qualified URL for this link. Then I need my relation property that's going to describe what is the type of link that this represents. And I also need another property to represent the HTTP method that should be used with a given link. Now, how do we construct a link? There are a couple of options inside of ASP.NET Core. The simplest approach could be using the URL helper. This has a couple of methods that you can call to get back a URL for a given action or a route, but the URL helper is only accessible as a property on the controller. So it's going to limit reuse to some extent. Of course, we could create a helper method that we can reuse from our controller methods, but I have a different idea in mind. Instead of using the URL helper, there's a service that you can inject in your controller called the link generator. And this exposes a very similar API surface. I can use the link generator to get a fully qualified URL based on the action or a route name. So this is the approach I want to take. Now let's say I call get URI by action. We need to provide the HTTP context, which we do have as an instance property of the controller, and then the name of the method. And I can use the name of operator to provide the actual method name. And then finally, I need to provide my arguments, where I have the ability to pass in my route values or query parameters. But this will only give us back a URI that we can return as the href value. And it's not going to give me back the DTO instance. So instead, I want to make a small helper service that's going to encapsulate what's required to create a link DTO. So inside of the services folder, I'll create a link service. And what do we need inside of this type? I'm still going to use the link generator, but I need a way to access the HTTP context. And there's an abstraction for that called the HTTP context accessor. And inside of this service, I want to expose just one simple method returning a link DTO. Let's call it create, and the arguments will be the endpoint name, the rel value, the method that should be used in the link DTO, and then I'll provide a couple of optional parameters. The first one will represent the values that you can place inside of the route, and I'll also include an option where you can pass in a name of a controller. This could be useful if I need to reference an action that is outside of the scope of the current controller represented by the current HTTP context. So this will be a nullable string argument, and I'll call it controller. So then I can get my href value by calling link generator, get URI by action, and I can use the HTTP context accessor to get my HTTP context instance. Now this could be null, so I'll use a null forgiving operator because I'll only be using this from an HTTP request. Then let's pass in the endpoint name, the controller, and the route values. And then I can return my new link DTO instance where I'm going to set the respective properties. So let's set the href value, the rel value, and the HTTP method. Now you will see that the href value could be null. So in this case, I want to throw an exception because this really shouldn't happen. If I get a null value back from the link generator, then the arguments that I provided aren't correct. So let's pass in some generic error message. For example, invalid endpoint name provided. And if someone tries to create a link DTO or an endpoint that doesn't exist, we're going to get an exception. So we're making sure that you always specify valid arguments when creating a new link. Now let's register this with dependency injection. We have a helper class now that encapsulates our service registrations, and inside of the add application services method is where I think it's most appropriate to register my new link service. So let's register it as a transient, and let me specify the link service. I can close this down, and I will go back to my habits controller. Now in this case, I don't need to update my DTO, the habit with tags DTO. And this is because I'm performing data shaping on this type to get back an expando object containing the properties that I'm returning to the client. And because this is an expando object, I can just as easily introduce my links. What I need to do is say shaped habit DTO, try add, and then specify the key and value pair that's going to be added as a new property on the expando object. So I can introduce the links property, and all I need to do is provide a concrete value for the links. Now we're going to be using our link service, and I want to make it globally accessible, so I'll inject it on the controller level. So let me add the link service, and now I can use it inside of my endpoint when fetching a single habit. So how do we add a new link? Let's create a variable that's going to hold this, and let me define it as an array of link DTOs. And now I just need to initialize it using the link service. So let's call the link service. I'll call the create method, and the first hypermedia link that I want to create is a self-referencing link. This will point to the endpoint for fetching this same resource, which is our getHabit endpoint. The rel value will be self, because this is a self-referencing link. And then for the method name, you can use the HTTP methods class, which contains some static fields that you can easily use to reference the specific HTTP methods without having to hard code them. So this will be the getHTTP method. And then I need to provide my route values, which is going to be just my ID. I already have this value, and I can provide it through an anonymous type. And that's all there is to it. Now I just need to include additional links to describe the additional operations that you can perform on a given habit. So let's say I want to reference the operation or endpoint for updating a habit. I can specify the update habit method. Let's call this operation update. The HTTP method will be a put, and the route values are the same. Then we also have a patch habit endpoint, and I could call this patch or partial update. The specific naming convention is up to you. I'll use the patch HTTP method, and then one more link I want to define is for my delete endpoint. So I'll reference delete habit, add the rel value of delete, and specify the delete HTTP method. So let's say I'm satisfied with my links. I'll add them to my DTO, and now we can start the application and test out to see how this is working. If you run into this exception, then you've made the same mistake that I did. And the exception says that we can't construct our link service because we can't resolve the HTTP context accessor. And I did this kind of on purpose because I think this is a very common error when working with HTTP context in ASP.NET Core applications, and that's forgetting to register the required services for the HTTP context accessor. So let's fix this. I'll go back to the application services and